Okay, in this presentation we're going to look at Project Euler question 16. Now this is a set of programming exercises designed to help students sort of practice their programming skills and learn more about mathematical programming. I am using Julia version 1.6.1 and I am using Jupyter notebooks. So anyway, the question is 2 to the power of 15, that is equal to 32,768. And if we split up the digits there, we get 3, 2, 7, 6, and 8. And we have to sum up those digits. 3 plus 2 plus 7 plus 6 plus 8 plus 6 plus 8, we get 26. So the question is, what is the sum of the digits of the number 2 to the power of 1000? Okay, so first thing we have to concentrate on here is actually sort of splitting up the numbers into digits. Okay, so what we're going to do here is take a number here, x 1 2 3 4 5, and then what we're going to do is convert that into a string. Okay, so let's just have a look at that. And when we have our string, what we will do there is just access the first element there. Okay, so essentially what it gives us is this Unicode here. Okay, so it sort of suggests this is like the actual character to create the digit 1. Okay, so let's just look at the length of x, just see how many we have. Did we pick up all of the ones we were expecting? Yes, we have 5 digits, okay, and these are, x is the, now contains the information used to print each digit, okay. But what we could do is actually transform x into an integer. Now, I'm using a 64-bit machine, so int 64 here. Okay, and what I could do here is transform each of those into back into a single integer. Okay, 49, was not expecting that. Let's look at the last one, 53. Okay, so let's just check what's going on here. Okay, so we had 49, 50, 51, 52. What I expect is 1, 2, 3, 4, and if for the fifth one, 5. So seemingly what's going on is that there's an offset there. We have to sort of correct the this output here by subtracting 48. Okay, so let's have a look at that again. So this is the first 4, so this should give us 1, 2, 3, 4. That's what I was expecting. Okay, so we have a sort of framework set up. This is the key piece of code here. Okay, int 64 so apply to each item of x, x1, x2, x3, x4, and then just subtract 48, and that gives us our digits. Now, the next thing we have to worry about is really large digits. Okay, so what I'm going to do here is calculate 2 to the power of 50. And that gives us a very large number. I'm not going to verbalize it there, but you just take my word for it. It's a very large number. So let's see if that works for 2 to the power of 1000. 0. This is essentially what they call a stack overflow error or something like that. It's a memory error. So essentially what we have to do here is it won't evaluate it immediately. But there's a way we can work around this, and it's rather than using integers, what we could do there is use big integers. Now this essentially creates more space in memory for much larger numbers. Okay, so big int of 2. Okay, so that has a different data type compared to just if you're writing 2. Okay, so let's just check that. So that's going to give us big int there. Okay, now essentially that means we can work with much larger numbers. Okay, so does this work? Yes, it does. Now you can sort of see that this is a massive number. Okay, 2 to the power of 1000, but Julia can handle it. Okay, I'm not going to even try to verbalize that, but it's got an absolutely massive amount of digits. Okay, so what we're going to do is start building up a program here. Okay, so the first thing we're going to do is set n equals to 1000. So we're going to just create a program here and start testing out our program. And then what we're going to do is evaluate 2 to the 2 to the n, okay, for some value n. But we're going to set it up such that the answer output can be a big integer, and then what we're going to do is convert that to a string, essentially. So that's what's going on there, okay. Now, so that's the number converted to a string, or 2 to the power of n converted to a string. And what we can do there is actually create a comprehension. Now I'm going to sort of do something a little bit more elaborate. I can pick out each one of those and just add them up. Okay, that's not really a hard thing to do. Okay, so this is a Project Euler 16. So I'm going to try and sort of use alternative approaches there. So what I'm going to do is here set up a comprehension. So I have some expression here for an iterable. Okay, here I'm just going 1 to 5. I'm just going to pick out the first 5. So essentially what I want this to do is give me the first 5 integers, and that's because I'm picking out the first 5 integers there, the first 5 characters, I should say, and give me a vector of those characters as integers. So let's see what that does. Give it a second there. There we go. So essentially, it's good. If I was to continue on with this, it would just give me each character as a single integer, as an element in a long vector. Let's just actually see how long it actually is. So length of n, 302. Okay. Now, so what I'm going to do here is create a function called Euler 16. Okay, and it takes in an input n, and immediately what it does there is calculates 2 to the power of n and converts that to a string. Okay, and then with that output, what it does is actually just takes each character and expresses it as a single integer and then just sums them all up. Okay, and then just prints it out. That's it. So the sum is 1366. Okay, and that's just the amount of time it takes to process that. Grand, or Project Euler question 16.